So here we're going to do a raffle, and our raffle is going to consist of 1,000 tickets that are sold at $2 each for three prizes. There's a prize of $500, a prize of $250, and a prize of $100. Everybody else loses, okay? So you're going to buy, you're a big spender, you're going to buy one whole ticket. You're going to find the expected value and interpret its meaning. Now let X represent the gain. Keyword here is the gain in money, okay? So the first thing I'm going to do is, in order to get the expected value, I need the probability distribution. So the probability distribution has the X values associated with the probability of each X value. So how do I get the X values? The X is the gain, okay? So when I gain money, well, it takes money to make money, right? So you spend $2 to play, okay? So you're either going to be a winner, a $500 winner, a $250 winner, or a $100 winner, or you win no money, right? If it takes $2 to play, the gain is going to be what? The gain is going to be $4.98. It's going to be $2.48. It's going to be $98. And it's going to be -$2. Those are the people who lost their $2 and didn't win a prize. So -2, 98, 248, and then 498. Those are the values for the gain, okay? Now the probability of winning no money. Well, how many tickets are there? There's 1,000 tickets total, and there's 3 winners. That means there's 997 losers. So there's 997 people who pay $2 and they get nothing. So your chance of losing is pretty high. Only 1 out of 1,000 get that $100 prize. 1 out of 1,000 get the $250 prize, and 1 out of 1,000 get the $500 prize, okay? The gain, we have to subtract off the 2 here because we paid $2 to play. Got to spend money to make money, okay? So what am I looking for? I'm looking for the expected value. The expected value is equal to the sum of the value times the corresponding probability. So the first value is -2. So my expected value is -2 times 997 over 1,000 plus, and the next one is 98 times 1 over 1,000 plus 248 times 1 over 1,000 plus 498 times 1 over 1,000. Okay? And when I type this in my calculator, so I get -2 times 997 divided by 1,000 plus, I'm going to do 98 times 1 out of 1,000 plus 248 times 1 out of 1,000 plus 498 times 1 out of 1,000. Enter, and I get -1.15. Now this is rounding. I should be getting -1.148. Okay? So what does this mean? How do I interpret this number here? How do I interpret this average, this expected value, right? So interpreting the meaning is half the problem. So what does this mean? You can expect to lose an average of $1.50 $1.15. Okay, so $1.15 for each ticket you buy. So who's going to be winning in the long run? It's the person that puts on the raffle, right? Every time you buy a ticket, you're basically giving them $1.15. Okay, so you're just playing for funsies, all right? And that's how they get your money. That's how they end up. That's why they do the raffles in the first place. It's not to give money. It's a way. It's to make money, right? Same thing with casinos. Those casinos didn't get all nice and pretty just by donations from people who really love casinos. They got all pretty because they set up their games so that they, on average, take some amount of money from you every time you pull that lever or every time you place that bet. Okay, they are designed mathematically to win in the long run. This is what expected value means, okay? And this is why every game in a casino is slanted towards the house. The house always wins at the end of the day because of statistics. The games are designed so that the house has a favor, and maybe the favor isn't as slanted like it is with the raffle. I mean, a raffle, everybody knows you're kind of just playing a raffle for funsies because the chances of winning are so low. But people actually think that they can beat the casinos. And the reason they have this perception that they can beat them is maybe the expected value is that you're only losing like 0.1 cent every time you play, okay? Now, it may not be that low, but here's the deal. If you play this, if you have casino customers come in and playing, and they play this game, 100 million times a year, they just profited $1 million on average because they're stealing a penny from you every time you pull the lever. Okay, so they don't have to have a huge margin like a raffle does, but they can have a slight margin here and still rack up, and that's how they get their gold palaces, right? Okay, guys, well, I hope this explains more expected value. And verifying it's a probability distribution, if you add all these probabilities up here, you're going to get 1, and each one of them is between 0 and 1. So yeah, it is actually a true probability distribution, okay? All right, guys.